All right, you're the final hardcore crew that stick around to the bitter end. We love you folks.
Best for last.
When I got tasked with stepping in and facilitating a bunch of sessions kind of late in the ball game here, this was the one I feel the least comfortable on because I'm clearly the stupidest person up on the stage today when it comes to hydrogen. It's not something I've paid much attention to, so I hope you'll have good questions for the panel because I probably won't. And the panel has lots of experts, and I think between their discussion we'll cover it. But certainly just from a layperson who hasn't paid much attention, you're hearing more and more about hydrogen. The bills that have passed, the Recovery Act bills and stuff, are pumping millions of dollars trying to encourage hydrogen, and you hear competition for hydrogen hubs around the country and all kinds of that. And I think the public sometimes is confused about, oh, okay, I don't have to worry about swapping out my methane-based furnace because they're going to pump hydrogen in my house instead now, and those types of things. So we've got a panel today made up of folks, and we're going to give them each a couple of minutes to introduce themselves and talk about why they're involved with hydrogen. I also just want to mention now, and probably mention it again, that the Pipeline Safety Trust just released a paper on hydrogen, trying to look at safety issues around hydrogen. It was written by certain people that I won't mention their names. They can mention it themselves if they want to, but if you've looked at it, and there is a link to it on our website, and on the back of your name tag, you have the magic little QR code that will take you right to it too. So why don't we just start at the end and take a couple minutes and tell us who you are and how you've been involved in hydrogen.
Sure, thanks, Carl. All right. Is it working now?
There it should be.
All right, okay. My name is Tianyi. I am a climate scientist at the Environmental Defense Fund, and my research has been focusing on climate impacts of short-lived climate pollutants like methane, like hydrogen. And in the past year, I've also been leading our work in hydrogen leakage, measurement, and I can't believe that the doctor in front of my name survived all of the copy and pastings. Just for full disclosure, there's nothing special there. It's just like all of the PhDs and JDs have been more successful at hiding themselves, and I'm not going to be particularly helpful in a medical emergency. But thanks for the opportunity for being here.
Yeah, Max Kieba, PHMSA's Office of Pipeline Safety Program Development Division. I'm here because they like to give me the non-controversial, not too complicated projects, but
Easy part.
no, but a long-term engineer before my current role, but also looking at all the impacts of, yes, this has been in our regulations for a while, but certainly there's talks of expanding a lot. You probably heard from our deputy administrator, a lot of considerations on economics and certainly climate, but also we still have a safety mission. So we are interested in hearing about and understanding the perceptions that are out there of, what's the public interested in, or is this even on the radar? So those kind of aspects. So as I mentioned on some of the other panels yesterday, my division's kind of a blend of policy, data, technical, merging all together. And I also say I'm not the only SME or one of PHMSA's SMEs. We have a team of folks looking at it from a number of different angles, legal, technical, and things like that. So yeah.
Thank you, Max. My name is Richard Kuprewicz. I'm president of Accufacts. You guys can go on the internet and figure out what I do. I have I just hit 50 years of experience in various aspects of pipeline, transportation, and refining. There's about 100 people in here, roughly, maybe a little more. Let me ask a question of all of you. How many of you have experienced a hydrogen release event in the room? How many can admit they have? Okay, I've experienced at least 10 in my career. All right? Probably the worst event was related to an air products and chemical industry release of liquid hydrogen out of a liquid sphere in an industrial center in Carson, California, about 40 plus years ago. At my age, they all kind of blend the decades. I'm not here to demonize APCI. They understand gas. They understand hydrogen. They know hydrogen explosions. To their credit, over 40 years ago, they installed a safety device inside that sphere. It didn't prevent the hydrogen release, but it reduced it substantially. It was amazing that it actually worked. It's amazing that it actually worked with liquid hydrogen. Mrs. Kuprewicz would have been a very rich widow because the explosion went off their site. It didn't injure me or kill me, but it got my attention. Fortunately, the one individual that operated the facility was inside the control room. He suffered some injuries. They had tremendous destruction, obviously, given the explosion forces of hydrogen. But to their credit, they were able to rebuild the facility fairly quickly. So I don't fear hydrogen, but it commands and demands much respect. That's about it for me.
Austin?
Hi, I'm Austin Hastings. I'm the Senior Director for Gas Strategy Execution and System Planning for Pacific Gas and Electric in California. Engineering by education, and my background has been over 25 years, so about half of Richard's experience. But my background is project management, engineering, construction, operator qualifications, operations, emergency response, liquefied compressed natural gas, so kind of the full gambit within the utility space. And for about the past couple of years, I've been focusing on gas strategy and decarbonizing the gas system. And part of that decarbonizing effort is looking at hydrogen and potentially repurposing the natural gas system to start accepting hydrogen into the system.
Good morning, everyone. It's quite a pleasure to be here. It's actually my first time at the Pipeline Safety Trust annual meeting. First of all, I want to say it's just fantastic, the breadth of audience you have here. I think on this important topic of safety, you need everyone's input, and so I really appreciate that. I was asked for some feedback earlier, and so I wanted to make sure that was provided. You guys do an excellent job doing that. I'm at TC Energy, and my role at TC Energy is energy transition. And I lead up a team that's looking at it from a technical, technology, and operations strategy perspective. And it's interesting, when you start talking energy transition, it's hard not to talk about hydrogen, ammonia, and all these fairly hazardous materials that Richard very well just spoke about. I mean, hydrogen is dangerous, right? And I think his report, is helpful to understand the implications of those hazards. Now, marry that with energy transition, you have an opportunity, but you have a challenge. And part of what my team is set up to do is say, how do we take on this challenge head on? How do we surround ourselves with the right people who understand the challenges of what we're trying to do here? Because the prize is that big for us, not just as a company, but as a society for energy transition, emissions reduction. So, with that said, what we're doing at TC Energy is ensuring we have the right type of energy problem solvers around us. We go to different conferences. In fact, I was just at the Canadian Nuclear Laboratories Conference last week on hydrogen safety. For those of you who may not know, hydrogen is used a ton in the nuclear industry. They've been doing it for decades, and there's a lot of learnings there for us to all learn from. And so part of what I hope to share with you folks today is part of this journey is learning from experiences like Richard just talked about, understanding it is a greenhouse gas like Tianyi was just mentioning, but it is a great opportunity for us as we progress the energy transition to assess, understand, and if it's not safe, we shouldn't be doing that. So that's what I hope to have a conversation with you today about.
Great, thank you. Well, just for some kind of background, a couple of questions early on, maybe this first one to Max. Can you just describe a little bit, Max, about kind of what is the current state of hydrogen pipelines and the regulations? Are they different that address hydrogen pipelines?
Yeah, so current infrastructure, we have, at least as of last night, about 1,500, roughly, 1,566 miles, total miles. So if you remember, that's in context of over 3 million miles we have out there. Roughly half interstate versus intrastate, maybe a little bit lean more to interstate. 19.7 miles HCAs in interstate, 74.7 miles HCAs in intrastate. Mostly currently in Texas, Louisiana, roughly 4 to 18 inches in diameter. I don't have information on pressures, things like that, but at least since 2010, we have had 5 incidents. Sub-causes of 2 of those, at least one of them appeared to be hydrogen-induced cracking with welds. Another one appeared to be with some internal corrosion from water dropout, so whether or not that was a function of the product or not. So again, we've had 5 incidents since 2010. That's about it for the infrastructure. And what we're seeing going forward is certainly, has been mentioned, a lot of talks about potential hydrogen hubs, things like that. So we'll probably see as part of that potentially more networks of interstate pipelines for sure. I know some, different regions are getting together with multiple states on where could these hydrogen hubs go or not go. So I think more people need to learn about it, particularly in areas where they might not even have hydrogen pipelines, and now it's being talked about. So hopefully it helps.
So are operators already mixing hydrogen in with natural gas, and do they have to tell you when they do that?
So I understand a lot of operators are exploring it for sure. One gap has been identified in the report, and I think our SMEs agree with, we do not collect how much percentages of blends that are out there. So they may be doing it, but it's, I should say they may be exploring it, let's put it that way. They're looking into it. So right now we do collect information on hydrogen pipelines, but based on our annual report data, it's based on what's the predominant commodity. So you can assume if it's more than 50% hydrogen, it's a hydrogen pipeline. There have been studies out there which are kind of interesting. If you do go to blending and things like that, which, I acknowledge there were some concerns written in the report, what's the right amount? There have been some studies that say 5% is okay. There have been studies that have said, if it's just 1% hydrogen blending, you should consider it a hydrogen pipeline based on some of the potential concerns and risks, things like that. So, yep.
Great, thank you. Tianyi, maybe we can pick on you a little bit, just to even, for the public out here that are as ignorant as I am about hydrogen, tell us a little bit why we're even talking about hydrogen. How can hydrogen help us, deal with climate impacts? And then maybe discuss a little bit about potentially what does the hydrogen economy build out look like? Sure.
I know that hydrogen has been a new topic for me and probably for many of us, so I'm going to start at a very high level. So as my colleagues have said, this is not a new molecule. We've been using this, and we use it about 10 million tons per year here in the US, and its majority as a chemical feedstock in refineries to remove sulfur. It's used to produce fertilizers. It is also used as a fuel, but in very limited amount. And it was a fun fact for me that we have been using hydrogen as rocket fuel for decades, and you all may already know. So for all of these hydrogen that's produced today, it is gray. And if you have heard of the rainbows of colors of hydrogen, and there's debate about how useful they are, but gray just really mean that it's very greenhouse gas intensive to produce hydrogen. It's the methane reforming as the common method, and they release, in addition to carbon dioxide emissions, also a suite of criteria pollutants that you can imagine, like VOC and particulate matter and things like that. But it is possible, and I should say over 95% of today's produced hydrogen is this carbon-intensive version. But it is possible to produce it in a more climate-friendly way. And two of the ways that are most talked about, one is to add on a carbon capture function to the steam methane reformers so that you capture the CO2 emissions, and that's called blue. And another one is you can use renewable energy, renewable electricity to split water into hydrogen and oxygen, and that is called green. So we are not producing neither of that a lot today, but we are thinking about producing it more in the future because hydrogen is a very versatile fuel. I should give it credit as is due. You can combust it for heat, for electricity. You can also put it in a fuel cell to produce electricity without any kind of combustion, which is actually quite remarkable. And from what we hear today, in the Department of Energy National Roadmap, is predicting about a 5-fold increase in, from zero production of clean hydrogen today to about 10 million tons in 2030 and then about 50 million tons in 2050. So we're looking at a very sharp increase, and essentially this molecule will become used at scale, depending on how you would define at scale. And we're looking at using this in I say you can use it in heavy industry if you need high heat to replace what is currently used as fuel, often it's natural gas. You can use it in planes, aviation, shipping, places that are really hard to electrify. Also, it can replace a lot of the use today, or all of the gray hydrogen used today that is produced in more carbon intensive ways. But there are some limitations to hydrogen. You know, it's not just a new shiny object. It is very intensive, energy intensive to produce. It is expensive, and itself is an indirect greenhouse gas. So whenever you release it, whether that's leakage or some sort of venting, you will create some warming in the climate. What that does is just start to undermine the intended climate benefit that we intend to achieve with hydrogen. And you know, among these limitations, and also I should say it's a very small molecule, it's the smallest one, so it's very slippery, hard to contain. It burns faster and hotter than compared to natural gas. And among these different limitations, there is one that is very critical, I think, to today's discussion, is this molecule is very hard to move around. It's expensive to move it around. If you think about a compressed hydrogen gas in a truck, because it is very not energy dense by volume, you transport a lot of volume, but not a lot of energy. So, you know, there are thoughts about transporting liquid hydrogen, but that you need to keep it at minus 250 degrees Celsius, which is also a challenge by itself. Even then, it is not carrying the amount of energy that we usually carry with the same volume of liquid fuel. We need to, you know, the cheapest mode, I should say, I think being proposed is using pipelines. I think we all agree that because of the buildup of the hydrogen economy, we're gonna have to move it around to some extent. So there is a recognition that we're gonna need pipelines as a tool, but the debate is in, can we use it in today's natural gas infrastructures? And do we build new? Do we retrofitting natural gas infrastructure, or do we just blend in hydrogen? And I'm personally not a fan of any of these, but if I would have to pick, I would think blending would carry a higher risk than the other two options.
All right. Well, let me pick on all of you a little bit. You know, want to talk a little bit about what kind of projects would be appropriate to pursue for hydrogen and what kinds of projects are not appropriate. And we hear a lot about, you know, distribution operators. So are we looking at blending in distribution? Will that mean blending in transmission too? Are we talking about pure hydrogen in pipelines somewhere, or will it always be blended? And will that take new pipelines, or can you actually take a pipeline that's been used for 40 years for natural gas and just convert it for hydrogen? Anybody want to jump in that? You wrote the paper, Rick. Why don't you mention a few of those?
Well, from a use of a pipeline transportation system, it's easy to say that's going to be the most effective, cost effective. The problem is that form of transportation can put more tonnage into a neighborhood than any other form of transportation. All right? It's tonnage that can be the killer. And as a representative of the public from time to time, the public will not take it very well being on the receiving end of a research experiment that causes the neighborhood to disappear. And none of you really want that to happen as responsible pipeline operators. And so I just tell people, you know, hydrogen commands much respect. I'm not a big fan of putting it into distribution. There's been a lot of work done in the last 10 years in trying to tighten up the leakage issues on distribution systems. The deal breaker for me on you putting hydrogen or hydrogen blends into distribution was the weakest link is the stuff that PHMSA doesn't regulate. That's your in-house residential buildings. They're subject to a whole different set of regulations that has nothing to do with pipeline safety. And so it won't take much release in a confined area to really magnify the explosive forces of hydrogen. So my paper basically says no hydrogen blends in distribution. Now you're welcome to debate that, work on it, discuss it, but when you have an explosion and neighborhoods disappear, again, I'm not here to scare you, you're going to have a revolution, and they're not going to tolerate that very well. So the acceptance of the risk is not going to be well received by the public. And that's the kind of stuff that pipeline operators have to deal with. The transmission is a little different animal. You might be able to find some smaller diameter transmission systems, even 50 years old, that could be validated integrity-wise. I don't want to take that away from the industry. But it's going to be a whole set of conditions on existing pipelines that set a very high hurdle. It's not illegal to put hydrogen into a gas system now. The regulations do not prohibit you from doing that. But if something really bad happens, it just amazes me how quickly a company can go through $1 billion. All right? I used to think $1 billion was a lot of money. Don't take the risk. Think this one through. There are many people in this room as responsible operators who will need to evaluate this and then look at it.
All right, let me go to Austin just for a second, because it's interesting just reading news articles. It seems like there's two major distribution companies in California, yourself, PG&E, and SoCal Gas. And SoCal Gas seems to be going all in on hydrogen, and you seem to be a little more cautious about it. Can you kind of talk about that a little bit?
Yeah, so I want to make sure that we're kind of separating the two issues, right? There's the pipelines that are built and designed to carry 100% hydrogen. So SoCal Gas has announced their project to transport hydrogen 100% through a self-designed system. And then there's the other one where you're going to, like Richard was talking about, where you're going to be injecting hydrogen into a pipeline system and there's going to be a blend. At PG&E, you know, we're very bullish on hydrogen, but it needs to be researched and developed, right? So I agree with Richard that there's a lot of unknowns about hydrogen, but I don't think we should summarily dismiss it. There are advantages to incorporating hydrogen into your natural gas system from a decarbonization perspective. It's not linear, so if you have 20% hydrogen blend, you actually only have a 7% CO2 reduction, but you are reducing your emissions when you burn that commodity. But I agree that there needs to be standalone systems. So on the distribution side, SoCal Gas already has a pilot program where they've built a small distribution system and they're testing what it does to plastics, what it does to regulators, what it does to meters, what it does at the burner tip. But especially in California, it's really an energy storage question more than it is anything else. Because the concept to really make hydrogen work is that you have to take excess electricity that is carbon-free, so hydro, wind, solar, even nuclear. In California, electricity, actually, they will pay you to take the electricity during certain times of the day and certain times of the year. So it's taking that excess electricity and making green hydrogen. And by the way, I hate the colors too. It should be more quantitative than the rainbow of colors. But you take that green hydrogen, which has been produced from carbon-free electricity, and then you either do daily or seasonal storage with it. So you make it during the day and then you burn it in a power plant at night. When you burn it in the power plant at night, it has less CO2 emissions than pure natural gas. Or you store it in the spring and you consume it in the winter or fall. So to do that, you have to have your transmission system, right? The hydrogen that's going to be produced is going to be at the industrial scale, has to go into a high pressure, high capacity flow rate type system, and then be compressed and put into underground storage. But there are a number of unknowns when it comes to how these pipeline systems will operate and react to any kind of a hydrogen blend, whether it's 5, 10, 20, 50%. So at PG&E, we proposed a standalone gas transmission demonstration project. It's in a very rural area, but it's designed to, the concept is you would build what's called an underground bottle type holder. So you would take vintage and new pipe and you would build this pipe, and then you would have compressors and regulators and meters and everything that you would find in a gas transmission system, and you have to test it. You have to test it at various blends. You have to test it at various pressures. And you have to test it for years, potentially decades, before we would even be willing to accept it into our gas transmission system. There's an analogy that I'll draw with a pipe called ADYL-A, ADYL-A. Some of you might be familiar with it. PG&E was very bullish on ADYL-A in the 70s and 80s. We put in thousands of miles of ADYL-A pipe, and we've had multiple failures from it because it turns brittle after about 10 years. And we've had explosions, and we've had injuries to the general public. And now we're spending hundreds of millions of dollars a year replacing that ADYL-A. We cannot repeat the same mistake when it comes to our gas transmission system, right? Those that don't learn from history are bound to repeat it. So we have to make sure that we get the proper testing in place, that we can assure ourselves that, yes, we can safely do it at 5% or 10% or whatever it is. And again, that's going to take years, if not decades. One of my concerns, and this is where a little bit different than SoCalGas, is that you have a lot of these environmental groups or state agencies, CEC, California Energy Commission, CARB, California Air Resources Board, that are really pushing on the CPUC, our Public Utilities Commission, that are talking about forcing injection standards onto the utilities within the next year or two at 5%. PG&E's position has been, no, we're not going to put any hydrogen into our pipeline until we can prove to ourselves that we can do it safely, that we can have a proper asset integrity management program. Only then will we incorporate hydrogen into our system.
Roland, as the energy transition technology person, you must think about this a lot, especially on transmission pipelines. What are some of the concerns you have about hydrogen and how it could affect pipelines?
Yeah, no, absolutely. I mean, I think what's good out of this conversation is you're hearing the versatility of hydrogen. Now, the question is, you have a tool that's quite versatile to help reduce our greenhouse gas emissions. Where do we apply our tool? And just because it's a good tool, should it be applied? And so, you know, we had a number of customers come to us last year, and I think even the year before, to say, hey, we're either producing excess hydrogen, can we put it in your pipes for storage, like Austin was mentioning it here? Or, hey, we're trying to test out some of our equipment, you know, end user industrial site, run it through a gas turbine for power generation, just a small amount. Could you help us, because we tie right into your system? And when we looked at our system and said, look, where, you know, from an integrity management perspective, what makes sense and how do you start? Because the biggest question for me is, how do you start? The above ground equipment is quite complex, and it's not necessarily complex from the breakdown of the equipment, but it's just the release of hydrogen you may have, and the fact that your staff might not be aware of what they're working around, or we talked today a lot about emergency response. How do you get them aware of all that? So our focus on hydrogen, and if we're going to blend any type of hydrogen, certainly exactly like Austin said, we're going to do a lot of testing and due diligence before we introduce a single molecule of hydrogen to the pipe that's not already there. But secondly, we're going to focus just on where you can have a dedicated customer who's also evaluating it in the same manner, and you have best practices as to how you're going to manage it together. We're not going to run it through any above ground facilities. It's going to be strictly a pipe evaluation. And so that's what we're focusing on. But, you know, just the added piece in all this is we're still trying to learn. And we're working with a lot of organizations internationally on what are they doing. Like in Europe, they're further ahead of the curve on putting hydrogen in their pipes or evaluating it. And they certainly have very different pipes than what we have here in North America. But the rationale for the decision making is very helpful. Like, how did you break down? So we've asked them some of these questions, and it's been very insightful to help us frame what will it take for us to be ready to start to do that.
Great. You read that there's been a handful of communities around the country that are trying to kind of ban the use of natural gas and pushing electrification in our homes. And then there's a variety of communities that are trying to ban the idea of banning natural gas. So welcome to U.S. politics. But I wonder if we could just talk about that a little bit compared to, blending hydrogen in a distribution system and using it in our homes versus just electrifying our homes and perhaps using the hydrogen to generate the electricity in a more local spot. What are the trade-offs versus trying to use it in our homes versus just going to electrification and not going down that path at all? Anybody want to?
Sure, I'll get kicked off with that one. So, first of all, there's a huge cost to electrification. So it's about $25,000 per customer. So with PG&E, we have 4.6 million customers. It's about $115 billion. So if you include all the utilities in California, that's about a $300 billion cost to electrify. And electrify does not eliminate risk. We should know between the Camp Fire and the other wildfires that we've suffered and frankly caused over the past couple of years. Plus, you have to look at customer acceptance. We did a survey asking customers, would you be willing to electrify? And about 30% of them said, yes, we're willing to do that as long as it's cost neutral within 18 months, which is not. Because in California, where electricity is admittedly very high from a cost perspective, the cost of electricity is about 3.5 times natural gas. So it's going to cost consumers more if you electrify. Plus, people want to cook with gas, so they don't really care that much about their hot water heater or their dryer, but they're going to want their stovetop to be natural gas. And I'm electric only where I live, and I have a heat pump, and it is not very effective in trying to heat my home. It's very frustrating, and so people are going to want to continue to keep their natural gas furnaces as well. So there's a lot of questions that are there, but I think it's very problematic to just sweep across the board and say, yeah, we'll just electrify all the customers, and that's the best way to decarbonize the economy.
Anybody else?
I think I'll take that on, and I'll probably make a counter argument. From the energy transition climate benefit perspective, which is essentially what hydrogen is trying to do, the end goal, that electrification will definitely be better in terms of achieving, the climate goal. Let's think about, blue hydrogen. You produce with natural gas and then blend it in, which means you do reduce carbon dioxide emissions at the end when you burn the product, but you also increase the upstream methane emissions because now you have to lose some energy as your steam methane reforming. So then the upstream methane demand will increase, natural gas demand will increase, and that leads to more upstream emissions. If we're talking about we're blending green hydrogen, which is split with water and renewable electricity, when you have 1 kilowatt hour of renewable electricity, when after it's done with hydrogen and the hydrogen is ready to deliver, you only have half of it left. So it's really a big issue of energy waste on that front. And, I know that it's definitely true that there is a cost in electrification. There's also a cost in blending in hydrogen or try to transition into 100% hydrogen. But I want to challenge them and say maybe the electrification cost would change as we're transitioning from what we're using today to a more clean energy system.
I can maybe add something to that. I think the point I really appreciate from what you said, Tianyi, is that maybe the cost of electricity will change. And part of what as part of the energy transition, what we're seeing and what we're learning is it's a transition. And as a transition, you'll have certain energy modalities that serve you well for a decade. The next decade is something else, and the next decade is something else. That, to me, seems to be the reality of how the energy transition is playing out. So I'll give the example of our decarbonization plans at TC Energy. So we've committed to reducing carbon intensity 30% by 2030 and positioning ourselves for net zero by 2050. As we look to our 2030 target, all the technologies to get there are here today, and none of them include hydrogen. When we look beyond 2030, it's actually a big question mark. How are we going to actually get to net zero, and what tools are in the toolbox for that? We have compressor stations that are not connected to the grid today, so electrifying those compressor units with a grid means you have to build a grid. Building that grid isn't cheap, isn't easy, and in a lot of cases it's impractical. There's opportunities where you can take hydrogen, run it through essentially a methane pyrolysis system, break down the carbon and the hydrogen, you get solid carbon, you get hydrogen, and then you could run it through your compressor station. Those are some of the things we're evaluating. That may not work out for a whole slew of reasons, but that's why we believe you need all of the above solutions at the table. They all have a place, and they all have a place in time. I'll give the example of the Canadian Nuclear Laboratories again. They're looking at small modular nuclear reactors. I mean, that's blowing my mind away, but those are the types of things that may be there in 40 to 50 years. Hydrogen will help us bridge that gap in the interim, potentially, or not, but we do need to evaluate it. It's kind of what we're thinking and put everything on the table, because the challenge we have ahead of us when you really put your thinking hat around energy transition is it's vast, and the time we have is short. And so, it's what's framing our position around all the above need to be on the table, but you need to lead with safety to get it done.
If I could just continue on with that R&D thought, there's a lot of research and development that needs to occur. The one that I wanted to mention is what's called synthetic methane. So you make your green hydrogen, you combine your green hydrogen with a CO2 stream, you put it in what I call a magic box, and inside this magic box has sandstone and microbes that will then take the hydrogen and the CO2 and they'll spit out methane. So then you put that methane into your pipeline system. There's no integrity management concerns because it is methane. You consume the methane, you release the CO2, then you capture that CO2 and combine it with your green hydrogen. So your energy source is green hydrogen, but you never have the integrity management concerns of having to put that hydrogen into your pipeline system. So there's several companies that are doing that. Demonstration project is coming in Maine next year, which I find fascinating, and to me that is that is the method that if we can make that on an industrial scale as well as economic, we'll solve a lot of these problems that we're faced with.
It seems, go ahead, Rick.
I was just going to add just an additional comment to build off of this. First of all, a lot of people in this room are fairly young. That's a good thing, all right? Us old guys have got to hand over the baton to the new groups. And we've left a hell of a mess for you, but you'll rise to the occasion, all right? The history, we're Americans. We'll solve problems. If we keep talking and working, we don't look for just a single solution. The big challenge, the industry has a lot of experience, especially in refining, on industrial hydrogen and its use. It's when you shift it into the public arena that the risk factors go way up exponentially. So there's a way for us to reach that. There's so many opportunities here, they're kind of getting in the way, especially when you start throwing a few billion as incentives. So I'm encouraged by what I'm hearing at this discussion. The purpose of the paper is to get people to think about this stuff and to start respecting it and not get surprised. But I think we can get there. So there's positive ways to deal with this.
Yeah, that kind of segues right into my question. You know, when you read about hydrogen, there's lots of money, hundreds of millions of dollars being pushed out right now, pushing hydrogen hubs. You see communities competing with each other. So that's really pushing people to use hydrogen. How do we ensure that we're pursuing hydrogen projects that actually achieve greenhouse gas emission goals versus just spending money to create jobs? And it seems like the spending money part and all the research that's needed to do it right, how are those going to sync up so we aren't doing dumb hydrogen?
Transparency, a much overused word, but in America it carries a lot of meaning, checks and balances. You'll get a lot of different opinions, but eventually they'll gravitate to common sense. That's my perspective. It doesn't always get there right away, but
I would use the word caution. And Richard, am I old or am I young? I'm
You're young.
I'm young. Okay, I'm
It's all
52.
relative.
I'm 52 and I'm young.
Oh,
I
that's
guess because
still young.
Yeah, you started in the industry when I was 2 years old. I would use the word caution because the DOE and the money that they've released for these hydrogen hubs, it's on the tune of $9 billion. And I've been, Bill Karam and I were at a hydrogen conference in DC in September. And I think I get invited to a hydrogen conference about weekly at this point. You guys probably do too. But it's a gold rush out there. And it is just a feeding frenzy of people and consultants and companies and utilities, and everybody is just chasing the money. And my concern is this frenzy is going to get ahead of itself, and there's going to be a catastrophic hydrogen incident because somebody got ahead of themselves, and that's going to taint the entire industry.
Well said.
I really appreciate that comment as well. Give us some time. I know time is really limited commodity today, but it's a climate solution. I know we can't wait, but we can't get it wrong either. There's no missteps anymore. It's definitely an emergency situation. So give us time to do the research, to demonstrate, to collect data, to be transparent about what it is a good use for hydrogen, what it is not. And that really takes a lot of effort to figure out.
Yeah, environmental policy has to follow safety policy. You can't do it the other way around.
Are there examples of where we're kind of construction ready to use hydrogen at this point, where it makes sense to start using hydrogen at this point? Short new pipelines to industrial facilities versus the idea of blending, or is there more research needed for everything?
Not in my world. We're not ready anywhere.
And just, you're speaking distribution, I think.
No, transmission and distribution, both.
I mean, we have hydrogen pipelines today, right? So I think if you're doing industrial-based.
But I have natural gas pipelines.
Right. So I'm just thinking, if you're moving hydrogen, like new hydrogen production hubs to a storage site, because storage is going to be a big challenge for them, underground salt caverns, that's a meaningful project. It's maybe within state, right? And so I think we have to say those might be opportunities to help trigger certain key aspects of the hydrogen economy where it makes sense. But to your earlier question as to how do we ensure it's minimizing greenhouse gas emissions, that is a very important question. And the way we look at carbon intensity from creation of the hydrogen to end use is a very critical question that we need to get aligned on and use aligned metrics in how we assess that. I'm
out of my questions. Do you have any questions for each other? People read Rick's
Well,
paper? Was there anything in there you want to disagree with?
And on the environmental side, we talked about the hydrogen release itself, but there's also some reports that when you burn a hydrogen natural gas mixture, you release NOx, which you don't when you burn natural gas. So that needs to be studied as well. And I read Richard's paper, and I think his conclusions were never in a natural gas system, and I think we need to do the R&D before we can come to those conclusions.
That's fair.
But I'm just young, Richard, so.
Questions from the public? We got some microphones. Linda up front here needs one, Glenn.
I always have a question. So this has been a fabulous panel, by the way. I love it. Very, very intrigued by everything that's said. My question has to do with the use of hydrogen overseas in Europe. I understand they are ahead. They've already used it. They already have systems in place.
Different system.
I'm not real familiar with what those extent are, but can anybody speak to experience from the European community?
Might be a subtle segue plug, but we do certainly interact with our colleagues UK, HSE, and they, I believe, or they're going to try to be, or there's some might be discussions at our upcoming December workshop drilling more into our engineering and research division, communicating with them. So there is a lot of talks definitely with the UK folks for some of their experiences. Along the learning aspects too, given we still have a very limited R&D budget, but we at least have 6 projects coming out on the street now, already awarded. Everything from compatibility to decision trees to leak detection, which hasn't been talked about, but that's a whole other question too, and repurposing existing lines. So yeah, we are definitely engaging with some of the other folks.
And while you got the mic, Max, and maybe while Linda, I guess Linda doesn't have it anymore, but I was just wondering if PHMSA is looking at anything new regulations needed for hydrogen. We see this coming at us, and yesterday we were talking about CO2 and people are saying we need a moratorium until we figure out all this stuff. Same could be said for hydrogen. If people are allowed to blend it at this point and people are saying it's not safe, how do we deal with that?
I think I saw Linda point at Alan, so I don't know if Alan wants to. Thank you, Linda.
Tristan's still in the back somewhere.
No, I think it's fair to say, where it's a potential, there's things we need to learn, but you also heard we have a long list of things in high priority, but I'll defer to Alan if he wants to say anything else.
Good question. We are taking a look at it. We're keeping a close eye, as evidenced by Mac's involvement. We have a crew that's working on it back in Washington, and across PHMSA. But we're looking at what we can do now. We have a lot of irons in the fire related to hydrogen. Research, in particular, as noted by this great panel, needs to be done. We need to know more. So as we look to the potential for hydrogen blends, or whatever's put in the pipeline. I mean, currently we have things like propane air put in pipelines, and we don't track the product that goes in, but we need to modify our requirements that address the threat. And that's why we're trying to get smarter through research, and then we're looking at what we can do now related to, say, emergency response, how you respond to an incident, that sort of thing, in anticipation of this. So we are taking a look at it. And we are looking to, see what we can put out in the short term.
Just a very quick note. We don't want to get ahead of ourselves, right? If we move very quickly and we issue regulations or whatever, and we make modifications, and then we find out, whoops, we went the wrong direction, or we didn't incorporate everything we should, there's a sweet spot at which you have enough information, you are asking for time. So we currently regulate hydrogen lines, right? We regulate methane lines. So we're keeping an eye on it. We have safety authority to, if we see something that's not safe, we have the authority to move. But when you're talking about regulations, like Alan said, we have to do the research. We have to do it right. It's too hard to undo a mistake in a regulatory scheme.
And we don't know yet.
Okay. I wish you'd have gave me that seat up there so we could actually talk about pipeline safety instead of the use of hydrogen. So hydrogen, it's 423 degrees below zero for the boiling point. There was a lot of concerns with CO2. That's only 109. CO2 is hot compared to hydrogen. When I used to work with hydrogen, it could crystallize the oxygen in the air and burn you. So when you're talking pipeline safety, in my mind, I'm thinking, are you ready for this? If somebody has pure hydrogen, you got to make sure you got the right cryogenic gaskets that are compatible with 423 degrees below zero boiling point. I've seen nitrogen explode, storage rail cars, just from sitting there stagnant. So if you got a pipeline, I want to make sure that they're not down, leaving that in the pipeline. I want to make sure all these little things are being thought out, because while I'm supportive of it, other than the fact that it's killing my portfolio on stocks, it's got to be handled extremely differently. And I've seen first responders in Columbus, Ohio, when they had a tanker flip over, they blocked it off for miles, but they never looked at the thought that it's going straight up in the air. And people were right above it with cigarettes. This is 500 times lighter than air, so the expansion is crazy, but it goes vertical. So your first responders need to know exactly how to respond to this, and your regulators need to ensure that this is being handled correctly, because this is an extreme cryogenic, not something to be taken lightly.
All right, I guess it's me. Okay, name's Dante Swinton, Center for International Environmental Law. I'm in Baltimore. I'm a little concerned. I think that there is a little too much optimism around having hydrogen be this end-all, be-all solution to minimize our carbon footprint. For one, we still have the majority of hydrogen being produced by methane, which means you now have your upstream methane emissions, you have your emissions while you're trying to do the steam methane reforming process. That's a whole thing. You also have a situation in green hydrogen. You're putting a lot of energy into the electrolysis process that could have just been used as renewable energy for the system itself to power the grid. It doesn't really make any sense to me. Further, I appreciate that there's a greater level of R&D concerns, but you still have to think about the fact that hydrogen will end up embrittling a number of types of pipes. So how much research is being delivered to the level of pipe type that you need in order to make sure that there's no corrosion, that there would not be any sort of incident with that pipe rupturing. Like, there are so many pieces of this puzzle that are like decades and decades and decades of research that would be necessary to deal with that. When you already have the ability for renewables coming, the prices are far lower than they used to be. You have the prices of battery power diminishing. Like, why would we even commit the energy to something that isn't going to be safe for some time, that would be too expensive when it comes to the pipe that you would need to make sure that there would be any sort of hydrogen embrittlement? It's just seemingly just jumping ahead of the gun here, and we shouldn't be talking about any of this. We focus on the CO2 pipelines. There's barely enough regulation around those. So why are we now jumping to the hydrogen and having that as a concern? There's so many pieces to this puzzle, but I'll stop there.
So a couple things on that is, I think all options should be on the table, right? We're in an environmental crisis, so we should be looking at all opportunities to decarbonize our energy sources. In California, primarily, when we're talking about manufacturing hydrogen, it's with excess solar, excess wind, excess hydroelectricity. So when you have that overproduction of electricity is when then you manufacture your green hydrogen, and then where do you store that excess electricity? So we're talking about delivering electricity to the grid. We're talking about charging all the battery systems that we have, and they have their own environmental problems. And then whatever excess electricity we have, that is carbon free. We then make the hydrogen and we store it for either nighttime use or later in the year. But from an energy storage capability, there's nothing that beats a natural gas system. So PG&E's natural gas system has 14,000 times the energy storage capability as the largest battery system in our service territory. But I agree with you, there needs to be years and probably decades of R&D before we can even convince ourselves that we can do it safely.
Yeah, I mean, and that's an issue too. Like, the fact that hydrogen isn't especially energy dense doesn't tend to make much sense to me or anyone in this particular area that's concerned about the build of not only hydrogen pipelines, but CO2 pipelines as well.
And it's not going to solve all the problems. It's one lever we can pull.
Yeah, I really appreciate that question. It's like you're living in my head. This is how I talk to myself every day. For scale, in debating what should be the final percentage of energy demand that's supplied by hydrogen, I think currently the anticipation for 2050 is between 5% all the way to over 20%. Over 20% might be too crazy, but I think it's also worth debating, should it even be as big as 5%? So just give some numbers to that context.
And I agree, great comment. And you brought up hydrogen embrittlement. I think that's a known potential concern. I don't want to get too ahead of what our R&D might play out, but they are looking at existing infrastructure. I have even heard anecdotally some operators saying, okay, yeah, we kind of agree vintage is probably not the best place. They're even saying maybe the newer performing higher strength steels probably aren't the best either with the hydrogen embrittlement concern. So it's not necessarily always looking for the newest best that's out there, because there might be a sweet spot out there. I do want to give a plug, so I know some standard bodies are looking at a number of different angles. There is ASME B31.12 that's out there, not currently incorporated, but I know there's one out there. It has some pretty conservative numbers in there. So, and I also know API 1104 is looking at welding aspects. I think API 5L is looking at different pipeline aspects. So yeah, but I think it's a fair point that hydrogen embrittlement is a potential concern.
Anybody have a new question? I see Travis has a question. Anybody else before we give people a second chance? Over there.
I just heard you mention 31.12. So if you're building or you're looking at building new infrastructure, is it safe to say that reliance on 192 and 31.12 is the right path to build, design, and operate a hydrogen pipeline?
Yeah, I think it's too early to tell, and since it's not incorporated in our regulations, we would have to go through the process of saying, is it reasonable to apply to our pipelines? I know it's a go-to out there. I know SMEs have looked at it, and there's some pretty conservative numbers out there on what they have for design and safety factors and things like that, which I anticipate our industry might have comments on that if we decide to put that across the board. But no, it's too early for us. We'd have to defer to our process to figure out that's the best approach. Yeah. But again, it is one data point out there. So again, it's potentially, if anyone's interested, something to look at if you're not already aware of what's in there. So.
Okay, to answer his question earlier, for our state in North Dakota, in the heart of the Bakken, we have a huge flaring issue with natural gas just being wasted. So hydrogen is the alternative for that wasted gas. That's why they're looking into it, for using natural gas and changing it into hydrogen versus just pouring it into the atmosphere. So that's one of the reasons it's being done in our state. And that's all I wanted to add.
Can you hand it over to your right there, Travis?
This is something I don't know a lot about, and it's been very interesting to hear from everybody. But I do know this. I know that hydrogen is like the smallest atom that we know. And what worries me about using hydrogen and putting it into pipelines is that it's about the money. And unfortunately, corporations want to maximize their profit, and sometimes they will sacrifice safety when they do that. So we got to make sure that the regulations prohibit that from happening. There's going to be a lot of stranded infrastructure out there as natural gas is being turned off, and that is happening. I'm from West Virginia, and we deny that the coal's coming to an end, but people who really know that the uses of coal are going down. They're not going to come back, maybe peak from time to time. So we got to make sure that we design the system. If we're going to use hydrogen, what kind of hydrogen we're going to use? Or we're going to put it in infrastructure just to maximize our profit at the risk of people. So I'm glad to hear this discussion, and another thing to keep you awake at night.
There's one way in the back.
I can just talk. Paul Weimer, e-consultant. A couple things you might check is Hawaii gas in Oahu has been injecting up to 15% hydrogen, synthetic natural gas, renewable natural gas. They've been doing it for quite a number of years, in the U.S. So that might be something to look at their experiences and stuff. Also, that was mentioned about the UK. There is a study called High Deploy. It's HYDEPLOY. High Deploy out of the UK has done a lot of extensive blending experience. The other thing I don't know that everybody's looking at is the gas detection side. And I know I spoke yesterday a lot of the current technologies see methane and not hydrogen. So you just need to make sure too, and first responders and other things, of what type of detection technology is out there. A lot of the older, somebody made a joke the other day, is let's go back in the museum and pull some of the older gas detection technology, a catalytic thermal conductivity, because that does see hydrogen, where some of the new laser-based tunable diode laser and some of the other things do not see hydrogen. So there's other things there to make sure you're using the right type of equipment. I also sit on the International Gas Union, the IGU, which is above the AGA, which is the World Gas. And we have a distribution committee there that has a whole subgroup on hydrogen. So there's a lot of hydrogen injection going on in Germany. There's Portugal, Spain, the UK. There's a lot of activity going on in that space. I mean, their big terminology now is let's repurpose pipelines for hydrogen, and they're talking 100% hydrogen. Again, I don't agree on a lot of all of it, but certainly a lot of discussion. So thank you.
Yeah, and I'll just add, good comment. Other ones out there, like I know DOE has their high blend intergroup that's looking out there. Leak detection, again, is a great example. We talked yesterday about the shift of approach from managing to fixing leaks, but leak detection equipment. But if you still rely on odorant, which is very popular in at least distribution, some transmission, there are questions on whether or not odorant is even effective, or does hydrogen do something to the odorant? So those things have come up too. So.
Yeah, I appreciate that. And I just want to add that it's not only we need to know where it's leaking, but also how much we're putting it into the atmosphere. This is a very similar story with methane. We don't want to repeat the story. So I want to note that the technology of detecting hydrogen, I appreciate Paul raising that, it's very far behind compared to what we have with methane today. And there's no commercially available instrument that can see hydrogen at parts per billion level within a few seconds. And that is crazy to me. We ought to be doing those better sensors and going to places that have been using hydrogen or injecting hydrogen to collect data and figure out how much exactly they're emitting.
We're at the end of our time. I don't see any more hands, but I want to give the whole panel a chance to, any last thoughts?
Yeah, sorry, I was just gonna, there's an interesting comment there where the pipeline conference, let's talk about pipeline safety of hydrogen. So just to give some color from some of the commentary I heard, there's the Pipeline Research Council has been around for a while, maybe many of you know that. They stood up the Emerging Fuels Institute last year with the sole purpose of looking at what research initiatives are our priority in all these emerging areas. And for hydrogen, I have it written here, pipeline integrity and safety, so that's really about the material science, the embrittlement that you all hear about, plus more. Measurement and gas quality, so I heard that come up, that's a priority for them as well. Compression stations and field operations and just the equipment around that is a priority. Inspection and maintenance, are the current ILI tools good enough for a blend of hydrogen? What blend of hydrogen? What are they missing? What are they seeing, right? Then just even separation of the blended hydrogen or methane hydrogen just to get the hydrogen. So there's a lot of research going on. The Emerging Fuels Institute actually is a consortium of a number of operators, but it also has operators from Europe. So there's commentary around, are we learning from those folks? And that's what's been really interesting and good in this space is that a lot of folks are coming together. It's a very collaborative environment to learn fast because we have a time scale here. We're not gonna learn and just move too fast. We want to learn fast, so doing that together is our opportunity here. And I think we'll be quite impressed with the amount of research that gets done in a short period of time. At least I think I will be. And it's an opportunity for us, but by no means are we, at least I can speak on behalf of TC Energy, going to embark in this space without having safety top of mind.
Any other final thoughts?
So the last one that I would have is I think we need to make sure that we include our labor workforce. So at PG&E, it's IBEW. And I've met with their leadership several times, talking to them about gas strategy as well as hydrogen. A couple of months ago, I presented at the Inter-Union Gas Conference, which had all of the natural gas union leadership represented there. They're very interested in this, and they want to learn more about it. But it's very important for us, as far as these demonstrations and the R&D, to make sure that we bring them along with us and we address their questions from a PPE, testing, proper maintenance, so that they're comfortable in understanding what a natural gas hydrogen blend is well. So I just wanted to highlight that.
And I'll just mention, again, another plug for our public workshop in a couple weeks, our engineering and research team. And again, we're a team culture at PHMSA, so I do want to acknowledge, Sentha White's our Director of Engineering Research Division, Candy Bearcat, Supervisor of R&D, one of our SMEs, Vincent Hollahand. Linda said earlier, we're always interested in hearing more, so definitely if you're able to come to that, give us some input. We're always interested too, if folks are thinking about projects or things like that, reach out to us. Chances are we'll probably connect you with an SME just to talk about it, right? For at least at an SME level for sure. So I don't know if Travis has a finger up. But
One last thing is going to be on leak detection. Instead of focusing on the track, why not use thermal detection? You're going to have an endothermic reaction, some type of thermal detection above it with the soil stationary. You're immediately going to catch that 1% leak that you can't normally catch through regular detection. But some method of thermal detection above.
Last thoughts?
Well, hydrogen doesn't absorb any heat, so it has been interesting to try to detect it. I think maybe the currently most promising way is to still converting it to water vapor and then try to catch that water vapor. But that doesn't deal with environmental humidity very well. I can go on about this, but reach out to EDF, reach out to us, to me, if you want to learn more. And we're also looking to measure emissions at demonstration projects. So my fellow panelists, if you're interested, reach out to us.
Trying to change slides, but it has died, which is good because we're at the end of the conference. I just wanted to help me thank this panel for all the good work you've done. And feel free to track them down as they try to sneak out the back door if you still have some questions. And I just wanted to thank everybody for coming to New Orleans, kind of still in the midst of COVID and trying to have these discussions. I hope everybody has safe travels wherever you're going back, and that we'll see you all again next year. Thank you very much.